sample data, sample cases. Then, in case something wrong, and if mammogram shows something unsymmetric, the shape, so maybe the strong. There might be level of the breast cancer. The 5, 4, 3, 2, 1. The 5 is the positive case, right? And how do I know? Actually, I was diagnosed as the breast cancer, 11.1. Actually, in United States, the 5% of the breast cancer is for men. Really. In Africa, there is a country, the 20 or 30% of the breast cancer, 20% is from the men. So for me, so even I was diagnosed as the level 4. It's strongly, it's positive for the breast cancer. But when I took the mammogram, so it's negative. So fortunately, I survived. But anyway, so that is a training. Then probably medical doctor has something rule inside. In this case or condition, then it's a positive or negative. So if we can make the algorithm or computer code, that is called classifier. Okay? Then we can label it. This is a positive or this is a negative. So that is a classifier that can be used for many of the applications nowadays. Okay, so today we are going to talk about such a classifier, especially for the classification. So we have discussed about the two different types of the learning algorithm. One is the supervised learning and another one is the unsupervised learning. Mostly we discuss about this unsupervised learning, in other words, the clustering algorithm, before spring break. What are they? First, the unsupervised learning. K-mean is the unsupervised learning. And what is the unsupervised mean? Without training, without help, without supervision. So we'd like to analyze the data itself without any help of, without any labeled data, without any the direction. Okay? We analyze data as it is. On the other hand, the supervised learning means just like the medical diagnosis. So in this case, if there exists the lump on the breast and also mammogram shows the shape is the symmetric and also the age is the older than 30 years old, then this is the breast. And we have the breast cancer positive. We have the thousands of such a sample data. Okay? Then we train the run, what is the rule of positive, what is the rule of the negative. Okay? Then in case there exists the new patient, then we can predict whether this patient is positive of the breast cancer or the negative of the breast cancer. That is supervised learning. Why? Because we provide something, the experience, labeled data, okay, truth data. So that using such a experience, the supervised, we make the classifier. So in this week, this week and next week, we will talk about such a supervised learning. In other words, it's called the classification. Okay. So main difference is the supervised learning. Use the labeled data, then we can train. Which one is more attractive? The unsupervised. Cluster is attractive, but most of the real application use supervised learning. One of the problems, actually supervised learning still provide better the accuracy. Then if we have the patient data, can the classifier automatically group by positive case and negative case? Very hard to say, not easy. But the supervised learning, so using the classifier with the label data, so reasonably accurate the classify the positive and negative cases. However, still the unsupervised learning is attractive, clustering algorithm attractive. Why? Not always we can have such a labeled data. Sometimes the machine should decide whether I need to go this way or this way, whether this is the here or this is the anomaly, this is the anomaly. Can we label all the possible event? So sometimes not. We need to narrow down the problem. Because of that, we can get the sometimes better accuracy because we narrow down the cases as the, for example, positive or negative. It's a binary problem of the cancer. But if we have the general patient information, can the class, sometimes it may not. Even the medical doctor cannot identify whether there exists a cancer or not. If we provide just general information of the patient. Okay? So we should narrow down to address problems. So that is the difference between the supervised learning and unsupervised learning. However, it is true in the real life application, the supervised learning has been used a lot, still it's used a lot. Okay. So there are two types of the problem in the classification. One is the classification itself. It deals with the class label. So our goal is to decide the label of the class. In case of the breast cancer case, the breast cancer is a positive or negative. So either positive or negative. That is the classification problem. However, prediction, numeric prediction, deal with something, the continuous value. Okay? So it's slightly different. But don't pay attention too much, it's such a different. But that is the general term in the data mining. Okay? So basically the classification process consists of two steps. So today is a weird day. So I got the third time phone call, which is rarely happens. I think that is because of my daughter's birthday. Today is my daughter's birthday, so it's called from my elder sister who lives in Hawaii and Korea. Right now, Korea is the morning time. So, but I'm sorry, I forgot to turn off. Anyway, so there are two steps for the classification. First one is training. Okay. Anyway, without training, we cannot build a classifier. Okay. So based on the training step, then the next one is use that model to predict, to decide the label of the new data. Okay. So training and the other one is called the testing. So training and the testing step. So mostly the important part is how to construct the model, how to train the data. Okay? Using the model is straightforward. So in case of the research, we can evaluate or estimate the accuracy. We need to prove how much accurate for the constructed model. So how to evaluate is another issue and important research issues. So in your project 3, so you guys think about how to evaluate, how to prove the accuracy of your research also. Many of the research just focus on the accuracy only, but the accuracy we will see. It depends on, okay? So in the extreme case, so how many the Ebola virus positive? Even though it's the outbreak in Africa, so if we randomly select the 1,000 of the people, one, even less than one, okay? So I have classifier. I can diagnose all the people as no matter what types of the symptom or whatever, it's all negative. Accuracy, it's mostly 99.99, right? Right? Am I correct?
Yes.
Yes. But we cannot believe that this kind of classifier. We need to evaluate classifier different way in case of unbalanced data. The positive and negative is extremely unbalanced. 99% is the negative, but only 1%, less than 1% is positive. However, we don't want to lose such a 99% is not okay. It should be 100%. So how can we evaluate such unbalanced data for the classifier? So we will see such a thing. So evaluation, estimate the accuracy is another important thing. Also, I build such a model using some 10, 20 test data. Okay, is that enough to evaluate? So I tested my classifier 10 times. Okay, 10 the test data, sample data. That works very well. Can I say this is the 100%? So we need to think about it. Sometimes your data. So I have seen a lot of the research that use this is my data set. Okay, then train make the model, make the classifier, then test with one of the sample. Okay, but this classifier already biased to the training data set. So definitely it will the test data, if the test data is selected from among the training, it will be already adjusted. So we cannot say, so this classifier is correct. I have seen a lot of such a research, especially for the student research. They use all the 100% data set as the training, then select randomly some of the data set, then test it, then they say it works very well. We need to think about it. So we will see how can we evaluate. But mostly in terms of algorithm, we will focus on the model construction step, first step, training step. Then we will see how to evaluate how to test it, such a constructed model. Okay, so this is the next few slides show how the classification is working. Okay, so this is our training data set. So you can see. So this is our training data set for what? It's a professor information, and our problem is whether tenure or not. Okay. So for example, my assistant professor has been 3 years of the assistant professor and not tenured yet. And N is associate professor 3 years, not tenured yet, but the Jim, associate professor 7 years, he is tenured. Okay. Using this one, we can train. We don't know how to train yet, we will see later. But it's a train. We have the classifier, or the model, or rules. Okay, it doesn't matter how you can say, but anyway, we have this one, algorithm to decide. So this is the model. So we got the length is the professor. Okay, and or years is longer than 6 years, and the professor is tenure. That is our rule. Okay, that is the model. That is the classifier. Many of the real application in the, for example, the CRM, customer relationship management, they try to find such a rule. If you can find such a rule, or if you can build a model, you will be paid by the 10,000 or sometimes millions of dollars from the company. Okay? Why? Because they can focus on the only target customer. So I have the new laptop or the iWatch. So I'm going to advertise for the 40 billions of the old person. No, you don't want to spend huge amount of money. But if you can target on the specific the customer who are interested in your product, it will be better. Okay, so it can be used for the marketing also. So many of the company would like to find such a classifier, the model for the CRM, customer relationship management. I did one project in one of the, it's my old company, that 2012. At the time, I used the classifier using the R programming. What I built the model is the bank actually give the freshmen in the college, they can open the student account in a bank. It's the student card also works with the deposit, the debit card, right? So many of the companies, they compete. They try to put their the bank, the account to the student card, because it has a higher chance after the student graduate, they try to keep same account for the salary account later. Probably you realize you will get a lot of the direct mail or the advertisement from Chase Bank or the Bank of America. If you can open the saving account, we will give the $300, something like that. If you can assign the account as the direct deposit from the company, your salary account, okay? Because that is the first account where the customer receive the money, get the money, okay? Which means for the bank is so. Whether we can find the model or rules, which student will keep the same account after graduation. But surprisingly, it depends on the parents' the income. It's related to the parents' income. If the parents' income is a certain level, they don't want to move to other. They try to keep the same account because they don't want to be risky, because it's supported by the parents or family. So financially, they are stable. However, those who are not stable, the financial, they try to keep changing, move around. So how can the bank respond to such a model? So they can focus on some financial reliability, like the student loan, provide a student loan and with a fixed rate or something like that. So if they have the financially stable condition, they try to keep the same account, something like that. So that is the first process to build a model. Okay, then once we have such a model or classifier or the rule, we can use this classifier to test the data. These are the different from the training data set. Okay, this is a test data set. We don't know whether they are tenured or not, but using the classifier. For example, our classifier is the rank is professor, or the longer than 6 years is tenured. So we can guess no, because it's less than 6 years. Longer than 7, yes. So we can predict the Melissa is tenured. However, not always such the classifier is working very well. Sometimes cannot predict the incorrect. It cannot predict correctly. So this is the case. But George is the professor tenured. Yes, it's correct. And Joseph is longer than 7. So it's a yes. So what is the accuracy? So anyway, the 3 out of 4 are correct. Right? So this one, roughly 75% accurate. The classifier is very high. Okay, actually, think about the previous case that I performed. We have the 10,000 the student account. Among that, if we can increase usually only less 5 or 6% keep the same account after graduation. The other 95% leave. But if we can target on the if we can increase by the 5%, which means 100% increase by providing the model, target model, then the kid have such a student, it will be huge benefit. So there are different types of the classification. Most popular one, you probably heard about the decision tree. Okay, like the picnic. So picnic is always a big issue regarding to the weather. So when I was the kindergarten, I can't remember, frankly speaking, the kindergarten, what did I do? I cannot remember, but most of the time, the elementary school, we have the, every semester we have the picnic, but the day before the picnic day, I wonder whether the raining or going to the picnic or not, okay? So to decide, so such a picnic, probably you have seen the something tree. So temperature or cloud, then in this case, this is the picnic or cancer picnic, no, yes, or tennis. So this is kind of a decision tree induction. We will see such an example. Another very popular one is the Bayes classification method. Have you ever heard about the Bayesian rule in statistics? It's a very simple rule we will see. So using conditional probability, we can actually calculate the conditional probability, okay, using other evidence. So we will see how can we use such a Bayesian the theorem, Bayesian rule for the Bayesian classification. So we can actually estimate the probability of the class where each data belongs to based on the conditional probability. So we will see the rule-based classification. I quickly go over. Then we will see how to evaluate such a selective and the model or how to test that. And we will see, hopefully today we will see the ensemble technique or the bagging ensemble to improve the accuracy of the classification. Okay, so this is a decision tree. First, we are going to use the tree for the classifier. For the specifically data structure of the classifier, we are going to use the tree structure. So as you know, tree consists of node and the relationship parent and child relationship. However, we have the different types of node in a tree. Root node, which does not have the parent, only children node. Okay. Then leaf node is the opposite. It doesn't have any the children node, but it has only the parent. And internal node has both of them. So we are going to use such a tree structure to represent our classifier. So this is called the decision tree, and also sometimes it's called ID tree. I forgot what ID stands for, but the most is to say ID tree. Okay, how can we understand this one? Age less than, equal or less than 30 years old, and student I think that we don't need this one. They are not going to buy a computer because it's too old. And however, no? Oh yes, I see. So this is the class label of the student entity. Okay, then this is the class that we are going to decide. So buying computer or not. So we have the attribute age, income, student, and credit rating. Okay, then using this is the age, and this is student or not. So for example, less than 30 years old, and the student will buy computer. That makes sense. However, if they are, even though they are young, but they are not student, they do not buy computer. And what about the 31 through 40? Regardless of the income or the student status or credit rating, but 30 years old, 30 to 40 years old, they will buy the computer. I don't know why, but anyway. So this is if they're older than 40 years and their credit rate is excellent, they do not buy computer. Fair, buy computer. I don't know why. You don't have to try to understand this is just an example. But sometimes you can find such a rule that works. Okay? That is the reason why we'd like to use the data minus hidden values. If you can find such a rule intuitively, we don't have to use the data mining technique, right? So we want to, everybody knows the student will buy the computer because they need, okay? Well, if you can find such a older than the 40, if they have excellent credit rating, they will not buy the computer because they don't want to access because they have the money they reach. I'm not sure. But anyway, so this is the decision tree. We can use this tree to classify, to label the data, in this case whether we are going to buy a computer or not. So problem, how can we build a tree? Can you find any clue? If you see the decision tree, can you find how can we build this kind of tree from the training data?
Roles. Association.
Role?
Yeah, roles.
Roles of what?
Based on the roles.
What kind of roles? Roles of the attribute, roles of the data, what kind of role?
I think association between
Association?
attributes.
That is the association rule, right? We don't have to, but it's different. In association rule, if this one, that happens this. Only two, okay? But this one is, this decision tree will grow much bigger than that if we have the more attributes. Any other? We are going to focus on attribute. Attribute what?
Independent attributes.
Independent, that close.
Weight.
Weight. How can you decide the weight of an attribute?
From the training data, we can try to find
On the frequency.
Frequency.
numerical.
Numerical, what kind of frequency?
Frequency of occurring the same thing.
Same thing, that's close. In other words,
Frequency.
we try to find something class attribute, okay? So if we can find the attribute, for example, this one, so forget about the less than 30, only two labels of the age, okay? So we have the less than 30, so then so we have the test data set and by computer. So let's the student. And no, no, yes, yes, no, yes. I have a student and age. So student, no, no, yes, yes, no, yes. And age is a 10, 20, 30, 10, 20, 30. Which one will be better? Attribute to classify as a classifier. Definitely student. Why?
Less frequent.
Less what?
Values. That's frequent values.
Less distinct values. Like
Less. In other words,
Less
if
branch.
we use the student as the classifier, okay,
Less branch.
then we can get the exactly same class as our problem by computer. In other words, we try to find the pure attribute. It's called the purity or impurity. So if we select the age for the classifier attribute, age, so 10, 20, so less than 20 is no, but there's a, this one is also working. So I randomly put, so let's change. So 40, 50, 60. So there's no clue because it's all separated. So we'd like to find the attribute that can make the class, the pure class, as pure as possible. So for example, if we separate the data set as a student, yes, no, all of this is a fine, yes, and no, yes. Actually, we focus on this one in frequent item set. Okay, as I said at the beginning of the data mining class, most of the all the data mining algorithm is based on the pattern. So we try to find the attribute that can make the pattern. That pattern means, so if we can find the attribute that can classify this class of class has a pure of certain data, that is the best one. We try to find such an attribute as soon as possible first. So in this case, among age, income, student, credit rating, age is the highest purity. Okay, it's a classified like this one, this group, this group, this group is the. I think that is because of this one. So clearly, that the 31 to 40 age group always yes. Okay, that can increase the accuracy, right? So our goal is to find the attribute first that can classify the data into subclass. Each subclass has the pure data as pure. So all the characters, not always, but just like this one. So the less than 30, it has a sum of them. No, buying computer, not buying computer. It's mixed. Okay. However, they can be also classified using another attribute. So if we use the student first, okay, we can. That is not better than age. Okay. So that is the reason we selected this one. The problem is, still you may be curious. You should be curious. Then how can we judge? How can we judge it as such a purity? How can we decide this one is better than this one? So that is the key point of the decision tree classification algorithm. Okay? But our goal is to find such an attribute that can classify as pure as possible for the subclasses. Okay? So we already discussed about it. So such a classification algorithm basically is a top-down approach, and also it's a greedy algorithm. What does that mean, greedy algorithm? Greedy. So for example, think about the baby. Most of the baby are greedy because if they hold it, they don't want to release. Okay, keep going, keep moving. Okay, without considering any other. Okay, only focus on this one. Okay, even though I have the better toy or they don't